Okay, so we are in functions, day number 2. So the first page of the packet I sent you should be basically review from last class. Number 1 says, which graph does not represent a function? And your answer to the question is graph number 1. And the reason why graph number 1 is not a function is because it does not pass the vertical line test. There is a vertical line that intersects that graph at more than 1 point. So choice 1 is not the function. And that is because it fails the vertical line test. All right, question number 2, 3, and 4 are all under the same exact category. Question number 2, you're given a function that says f of x is equal to 2x squared divided by x squared minus 9. And I'm asking for the domain of f of x. In order for you to figure out the domain, you got to look at the fraction and just know that you're not allowed to divide by 0. So anytime your denominator is actually going to equal out to the number 0, you have to exclude those values. All quadratics get factored, so I have dots giving me x plus 3 and x minus 3. And when I set each one of those factors equal to 0, I'm actually figuring out the values of x that you're not allowed to choose as part of the domain. Why? Because these values of x make the denominator equal to 0. So in interval notation, the domain of this problem is all real numbers except for these two. So it's negative infinity to negative 3. But you have to jump over negative 3 and go to positive 3. And you have to jump over positive 3 and go to infinity. So this is how you write down the domain of the function above. Now, your next one, I give you a different type of question. Problem number 3 gives you the function f of x equals 1 over the square root of 2x minus 4. But the question is exactly the same. What is the domain? Now, in order to figure out the domain, you have a radical and you're not allowed to have a negative number underneath. So you have to make sure that the radicand part is more than 0 and also never going to be negative. 0 can't be in the denominator and negative can't be underneath a radical, which forces me to say that the expression 2x minus 4 has to be a value that is greater than 0. So when you solve this by adding 4 to both sides, you'll get that 2x is greater than 4. And when you divide by 2, you get x is greater than 2. But I do want you to write down your answer in interval notation. So the way you write down all values greater than 2 is you put a parenthesis with a 2, which means more than 2, all the way out to infinity. And this is the domain for question number 3. Now, question number 4, a little bit more involved. Number 4 gives you the function h of x, and I give you a radical again, and you should know you're not allowed to have a negative number underneath the radical. You could have 0. You just can't have 0 when it's in the denominator. All right, so I have this whole thing, and I want to know what is the domain of this function. Well, if you know that the radicand part, the x squared minus 4x minus 5, has to be positive, and it even could be equal to 0, that is what you're solving. But we have gone over this in a previous unit. You can't solve a quadratic inequality. You have to assume that you are looking at a quadratic equation. So your quadratic equation is x squared minus 4x minus 5 equals 0. But you should all be okay with factoring this. The factors are x minus 5 and x plus 4. But it's requiring, x plus 1. But it's requiring you to make a t-chart there. And if you do, the left factor, x minus 5, gets set equal to 0, giving you an answer of 5. And the right factor, x plus 1, gets set equal to 0, giving you an answer of -1. But remember, you were never asked to solve the equation. You were asked to solve the inequality. And inequalities always get solved on a number line. So whatever values you got in purple for the equation, those are the numbers that actually go on the number line. So I'll put my -1 here, and I'll put my +5 here. Both of those values get open circles, but because of the or equal to bar, they both get filled in. And we did go over the rule that if you have a quadratic that's greater than 0, you are automatically going to shade on the outsides. So this is a graphic solution of the answer for the domain of the function. The only issue is I want you to write it in interval notation. So what is the domain in number 4? Well, the domain represented by this arrow is -infinity to -1 inclusive. But the gap in the middle requires a union symbol. And the domain section for the right-hand side is 5 inclusive to infinity. And this is how you write down the domain for question number 4. All right, your next one, number 5. There is a graph that is actually drawn for you. And it says the accompanying graph shows the heart rate in beats per minute of a jogger during a first 4-minute interval. But it says, what is the range of the jogger's heart rate? Well, a quick picture of what you actually see kind of looks like this. When you're going for the range, you're going for the y values. Your entire graph, when you're looking at it, lies above this dotted line, but below this dotted line. Because when it comes to the range, you want to know the lowest y value, which is at 60, and you want to know the highest y value, which is at 110. So in the end, your range goes from 60 to 110. And I am using brackets because both of them are included. And that takes care of the first page of this assignment.